K-nearest news or KNN algorithm is one of the simplest non-parametric lazy classification learning algorithm. Its purpose is to use the database in which the data points are separated into several classes to predict the classification of a new sample point. Understanding the importance of KNN, we have come up with this tutorial on KNN algorithm in machine learning. Now, before we go ahead with the session, I'd like to inform you guys that we have launched a completely free platform called as Great Learning Academy, where you have access to free courses such as AI, cloud, and digital marketing. You can check out the details in the description below. Now, let's start off with the session.
Fine. So far, KNN, good. So now let me show you the implementation of it. Now the dataset looks a little scary, but it's very simple. So what do we have today in the dataset part is we have got these one of these central agencies from US basically. So what do they have is, let us say they have got some offices in Northern America, Southern America, Africa's, Europe, say Asia and Australia, for example. And there are some servers deployed on each continent, for example. Okay. Let us say these are the servers, and these things intercom, like they are connected to each other. They have some ping system and all these things. So whenever there is a data required by one office, it definitely reaches out to all the servers and tries to fetch the data out of it. Now, what they have done is they want to understand that if a signal comes in, okay, to my, or if there is a ping from one server to me, how do I authenticate whether it's a good thing or it's a bad thing? Like, is it a hacker intrusion or it's actually a server who's pinging me? And there might be many offices down the continent. So we are not sure what exactly they are doing. So what they have done is they have broken down the IPv4 or all these protocols. If you guys are aware about it, TCP IP and all these protocols, each bit in the protocol represents some stuff. What they have done is they are trying to represent them by one of these columns or some of these columns. So they have done is they have given some values here. Okay. And these are the name of the columns which they are focusing on. These are all technical attributes. Finally, they are saying this is a normal ping for me, and this is an anomaly for me. This is not a normal ping. This is something weird. Yeah. So now what they want to do is they want to build a small microservice or a small filter before the server. Let's say this is the original server. They want to build a filter here. So when the signal enters or a ping enters, they should say that whether if this is a normal thing, pass it across. If it is an anomaly, block it here. Something like a firewall kind of thing. Okay. So this is what they want to automate now. So what they have done is since the options are only two here, normal and anomaly, we can use KNN to do this. Now, why did I choose KNN for this particular data set is look at the size of the columns that we have. We have around 42 columns. Okay. So when number of columns increases now, we cannot go ahead with logistic regression and all this because it's going to give us a lot of data cleaning and a lot of issues are going to happen with the model. So for example, if I implement linear regression here, imagine how many betas we are supposed to handle. So in these cases, you can go ahead with KNN. Okay. Now, the drawback of using KNN here might be, I'll tell you one drawback, because these pings when they come, they should be very dynamic. Dynamic in the sense when the ping comes within fraction of seconds, they should tell whether to allow it or to close it. There should not be any much delay. But the problem with KNN is, KNN every time a new thing comes, what it does, it calculates its distances with other points. So if there are thousands, so in this data set there are 25,000 points. Imagine one new point coming, definitely it will take some time to take calculated distance. So be very careful. If in case time is not one of your KPIs, then you should not use KNN over there. But for now, we are okay. There is no issue with the time as of such here. So coming to the data set, this is how it looks like, the top 5 values. The shape is pretty large. So dataset.shape is nothing but 25,000 rows, 42 columns. I will say it's a mid-sized or large-sized data set, definitely. Not because of the rows, but I'm saying because of the columns. Too much. Now, in future, we are going to show you anyway, if you have these many columns, not all of them are important. But that comes under different modules and different stuff. So we are going to show you how to reduce some of the columns and delete them. without creating much problem with the data set. Okay. Next, if you want to understand the data type of each and every one, this is how it looks like. Okay. For now, the only problem here will be, if you observe, we have to calculate distances. Now we cannot calculate a distance between integer and object. Definitely not. Data type is not matching. So my next implementation or next thing will be to convert a categorical variable. What are these variables? If you look here, flag. These are categories that we have. Now we are going to convert these categories into numbers. So we have multiple techniques here. Last time we saw imputer, le.transform function. Same way, this time we are going to use one more different function to do the job. Now, moving on, okay, we'll come back to this dot describe later once we finish the imputing part of it. So guys, you use this dot describe function, right? Good. So what do you use this for basically? What majorly you get out of it?
Just calculate the quartile.
Quartiles, okay.
Minimum and maximum, yeah.
Okay, IQR stuff, minimum, maximum, good.
Yeah.
Anything else you get out of it?
Standard deviation.
Yeah, standard deviation. So yeah, the rows, I got it. Perfect.
Yeah.
So what do you do with these rows then? These columns, what do you do with that? Any innovative way we can use it? Okay, let me show you. The first thing that I do is I look at the counts. All of them should be kind of similar. If in case one of them is not, definitely there is a missing value. So you can use count or you can use .info function. If you look at .info also,
yeah,
we're not done here, but let me. Even when you use .info function, it's going to tell you if in case there was a missing stuff, it will definitely highlight it here. But it will not be able to highlight zeros. Why? Because 0 is an actual value, so it will not consider it as a missing value. So this is the first column that I use for. Second is mean and standard deviation. So we all know what it is. Good. Mean and standard deviation, we get it. But if we have 42 rows, is it good for me to understand means and standard deviations? I will say individuals will not work that well. So what do? Is I club them together. What if I plot everything into one plot? I know it's impossible, but just imagine everything is in one plot. Is the data very closely packed or is the data very loosely packed? This is what these two rows or these two columns are going to give me. Just have a look. Look at the data here and look at the data here. Look at the spread. You get my point? The variety of data, one is over here, one is over here. So I can easily make out how spread is my data or how loosely packed is my data. If in case it is very loosely packed, you can go and do a scaling. Scaling is very much important when you have extreme data points available. Because why? Because if you don't do it, you are going to end up into a lot of outliers, both sides, this side also and this side also. I hope you people got my point. Guys, simple?
Yeah, but it depends upon the different parameters. This says src underscore bytes.
Yes.
Maybe that's the reason maybe the mean is more.
Correct. So what are we supposed to do then? If we understand, okay, this is of a different unit itself, then we can ignore it. But in some data sets, everything sometimes is on the same scale or same unit. In that case, it is very helpful. We can, by looking at the mean and standard deviation itself, you'll come to know scaling is required or not required.
Okay.
Because a lot of people get confused. Okay, how do we detect scaling problem? So this is the way we can detect it. But yes, you can definitely identify. If in case it's something like this, ignore it. Ignore it. Ignore it. Apart from that, if you look at all the zeros ones, I feel they are okay. There is no much problem as of such.
Yeah.
But again, the problem is these are 42 rows. No, that's a column. That's the reason it's a little confusing. So once we get a good data set, I'll try to reiterate this concept. Next, let's check for null. Yeah.
Krishna, if in this the above code, I want the standard deviation is in the figure of 2 or 3 decimals and not in the e to power 02 of each cell.
Yeah.
Is there any way that we can do it in one way?
You mean this is -2 and this is +1? You mean that way?
I mean the entire standard deviation column. It's in the decimals. So instead of showing in the e power this, the entire column is only up to 2 or 3 decimal points and not shown like this.
Yeah, we can do that. Definitely we can do that. Let me show you how to do that. Very simple. So what we do is we copy this, okay? And we'll make a new one here. So we'll create one copy. We'll say summary is equal to, so it's a pandas data frame. So now once I have pandas data frame, what I will do is I will say sum. What is the column we want? We want standard deviation, right? So I'll say sum standard deviation dot cd, okay? And I will try to round it if possible. Let me check.
Yeah.
Okay, that's it. See, very simple thing is this is nothing but an array. Okay, you can convert this array. What I've done is I've taken this array and I've converted it into a pandas data frame and I checked it. So better check it once if it is pandas or numpy. Usually there's a lot of confusion sometimes. Once I did it, what I've done is I have rounded the stuff and I've put it. Now you already have the value. Now what you can do is you can re-impute this if you want in this data frame, whatever you wish about. Yeah, Ashish, fine now?
Yeah.
Perfect.
Once we know this for one data set, we can use this tactics. Any data set comes in the future, right?
Any data set.
Yeah. So that's the reason we should know all the functions, especially what exactly that will do.
Correct. So Raju, what do I suggest is if you come with practice and experience. So it's not like if we set 2 hours a day every day in 30 days we'll get it. No, it comes with some kind of experience also, like how many data sets you have dealt with. So if in case you get a data set and everything is going good, no, then I think it's not a good learning. You should. I hope you people get stuck somewhere so badly that you people learn out of it. No.
Yeah.
So I will show you. I will give you the complex stuff anyway, and even the projects that these guys have done. No, the projects by Great Learning is sometimes gets really challenging because if you want a perfection out of the data project, you have to literally slog for cleaning the data. But definitely, I will say give yourself a time of a year or so. You will get all these tactics one by one. Okay. Right now you will be knowing it, but it will not be on your active, what do you say? There are two things we talk about, no? Active knowledge and passive knowledge. Passive knowledge, we know it, but we do not use it every day. Active one is very handy to us. We always use it. So this will come once you keep progressing onto that. So I will say give yourself a year or so, definitely you'll get it.
And do you suggest this in the Kaggle? There are so many projects solved and kept.
Yes,
we can see the solution also to that. Maybe referring that and simultaneously doing that also, and the solution also has got different type of solution they have given. Some people given a very elaborated solution. Some people are given a very crisp solution there. Solving that along with in our Python will help us, right?
Definitely, it will help us. Yes.
Yeah.
Definitely, it will help us.
Okay.
But the only thing you need good amount of time for that. But I'm not sure how.
Christian, on this one, Christian, on this one, if you can just refer us a few data sets from Kaggle, because some of them are very complicated and we don't know which data set we should pick up at this stage that we can understand. If you can refer us some project that we should take up and practice on, that would be great.
Definitely, I'll do that. I'll do that for you guys.
And one more request for Krishnan, can you also give some of the data sets and some of the problem to us?
Definitely, I'll be very happy. I have got n number of data sets with me. Yeah. I will try giving you the problems, and probably after a week, I'll also provide you the answered solution for it. Not a problem.
Yeah.
Perfect. Noted. I'll make sure I supply you more and more data sets.
Yeah.
Okay, good. So my suggestion for all of you is, I got your problem point where you guys are struggling on to where to use what. You guys know the concept, I know that, but where to use what is the problem. So what do I suggest all of you is, please remember the data type, what you're working on, the very first thing. Okay, data type is like you're working on pandas or you're working on NumPy. Correct? So if you're working on NumPy, the whole picture changes. If you are working on pandas, whole picture changes. So first thing, you be very careful on what we are working on currently. Secondly is, If you are doing, see, the only thing what we do in this data science stuff is we take up the data, we manipulate the data, and then we give some results out of it. That's what we do. Now, for manipulations, what you guys remember is, if you are manipulating one cell, you are supposed to focus on that cell and do it. So you should know the location and all how to focus on. If you are manipulating the whole column, okay, you should know where to refer and what to manipulate. So it's like it's a very generic thing only. The only problem is sometimes we use NumPy, sometimes we use Pandas, sometimes we use a direct function. So this is where I think people are feeling a little difficult. So now what I will do is I'll try to give you all the three type of examples. So what if I would have done this using NumPy, or what if I would have done using Pandas, or what if I would have done using some other function, like we used imputer function, correct?
Yeah.
So now instead of imputer function, what we could have done is we could have written a for loop, and we could have said if we have this particular word in the column, replace it by 0. Even we could have done this for the whole data. Nothing wrong into it. Okay? So we'll try to do all three of them so that you guys know where to do what. Fine?
Yeah,
I'll try to change my codes like that.
That's exactly what we are doing. That's exactly what we are doing.
Perfect. So what I'll do now is
Kishan, on this, the first point that you said that it is important to decide whether we are using pandas. On the first point where you said that it is important to decide whether we are using pandas or NumPy, how does it affect the code, and how do we decide whether we should be using pandas?
If you want to play around with mean, median, mode, and standard deviation, all that uniquely, NumPy will be the best thing to move around. Okay, for example, if you want to generate a list of from 1 to 20, we are going to do in KNN today, just now, that we want a list from 1 to 20. So we can, at the time, we need not to use pandas now. We can directly call NumPy. We can call range function, if you people remember. And we say np.range, a range 1 to 20. So it's going to generate a list of empty list of from blind numbers from 1 to 19. Correct? So in those cases, we are going to use NumPy. But when you are playing around with a whole data set like this, when we are using imputer function, all at that time we have to go and do the pandas part of it. Definitely. Okay. So the first thing what we decided here was here itself, because we are telling we are using pandas. Guys, so, I hope you got it.
Yeah.
So I will specify. I got the pinpoint. I got the problem point now. I'll pinpoint you guys where we are doing what, so that you'll come to know. Okay, this is pandas, this is NumPy, or this is a different function at all. Okay. Perfect. So moving down now. Now coming to a very simple problem we usually face is called a target imbalance problem. Has anybody heard about it? Target imbalance. Now I'll tell you what it is.
Yeah, I think that was discussed in the class as well.
Okay, perfect.
Yeah,
so what is target imbalance? What is target? Okay, perfect. So what do we mean by target is? So target variable here was nothing but our normal signal or an anomaly signal. Now what happens is, for example, if one of the target, let us say normal is 1, anomaly is 0, for example. Let us say if the total number of counts of normal is say 400, for example, I'll say 400 here, and total number of zeros are 200. What's going to happen is, when you do test and train split, definitely the same structure is going to follow there also. So when you train your data is more exposed to get learnings from 1 rather than zeros. Why? Because number of 1 occurrences is more. So your data or your machine learning model will be better in identifying ones than identifying zeros. Do people agree with that? See, for examples, we have pandas and NumPy. Okay, on every implementation, I show you only NumPy in sessions. Whenever I feebly, out of 100 lines of code, 50 lines of 70 lines is NumPy, 30 is pandas. So what would I say at the end of my sessions? You guys will be better in understanding NumPy as compared to pandas. Do you people agree with that? Yeah. Similar to that happens in the machine learning also. So whenever you find a 10-15% difference between your target variables, if you look here, normal is 53%, anomaly is 46%. So difference here is around 7-8%. So it's not that bad. The target is kind of okay. But sometimes you might find a problem like this. What happens is, machine learning will be more better on identifying this, and it will be not good in identifying this. If in case our model is okay with it, if in case we are actually want to identify one only, then this works in our favor. But most of the times this is going to create a problem when the difference is more than 15-20%. Okay, so we'll keep this in mind. Down the line, when we come to this particular module, I will show you how do we identify target imbalance and how do we solve it. There are multiple techniques again available to do it, but just for your understanding, this is called target imbalance. But in this case, it is less than 10%, so it is not an imbalance issue here. If we plot it also, they are like kind of similar.
Krishan, if the underlying data is such that there would be, we expect that there would be some imbalance in the data. Still, do we need to worry about that, or can we go ahead with that?
No.
For example, when we're talking about anomaly, we expect the anomaly to be very small amount of numbers, not out of the total data set, not regularly occurring phenomena. So if the data points for anomaly are small out of the total data set, shouldn't we be okay with that, or should we just assume that?
Yeah, we should be okay with that, because see, we cannot change this. Like, we cannot tell them to give us both equal. It's injustice. But why do we go and play around with this is, let us say you implemented logistic regression, okay, for example, and the output that we get is around 76%, for example. And the confusion matrix that we would have got is something like, say, 100 zeros, 100 ones were identified properly out of. Let us say this is our confusion matrix where we have identified 100 ones properly and 20 ones we have not identified properly. Fine, it's okay. For zeros part of it, 50 zeros were not identified properly and only 10 were identified. So look at the accuracy. Accuracy is going to be a little lesser here. So when you have a problem like this, and when we detect that yes, this problem is coming from something like target imbalance, then we revisit the data cleaning part, and then we do our target imbalance cleaning methods, and then we revisit the code. We will again take the new data set. So let us say this is called target balance cleaner. So we cleaned it. Now again we take this model to our logistic regression model, and if in case this increases to 85%, for example, then we say that whatever it did.
Yeah, so you're saying these techniques are used in the second or third iteration rather than the first iteration itself.
Correct. Exactly. Now, when I show you this technique, target imbalance and all this, you itself will tell me that whatever we are doing is not good. We are creating a fake data. I will show you how to do that. And literally, I'll tell you, there is little problem here, because to match this up, see, if you tell me that this is 400 and this is 200, what we can do? We have to increase this, right? Or we have to decrease one of them. So if we decrease, then also it's a problem. And if we give a fake data and increase, then also it's a problem. So both the techniques are anyway going to create some problem. But after doing this, if we are able to get a better accuracy, then doing this should not be a problem. It all depends on the situation, how we are in. Okay. So this I will cover in very detail during our data cleaning session. I'll show you in depth. And once we do this, for example, after doing data cleaning also, we would have got a lesser accuracy, say 78%, not great. Then what we do is we take this particular data model, whichever we have done, through some stricter models like SVM, boosting. These are the techniques which are very strict. If in case we make a wrong move, SVM is going to compensate for it. So don't worry, I'm going to explain you, but I don't want to confuse you guys. So if we do something like this, even we have a antidote for that also. So now what are we doing? Okay, I've used again the label encoder only. So now to convert those categorical variables, we have 4 in number. All 4 of them we are converting into continuous numbers. So this is as usual the label encoder only I've used. There was a little problem of scaling. So why did I say there's a little problem scaling is, first thing, I'm ignoring the source bytes and distance bytes. I'm ignoring those things and I'm saying these are natural numbers, these are also natural numbers. So I'm going to consider them in one plot and go to why? Because we are going to calculate the distance. So keeping this in mind, what I'm doing just to be on the safe side, I've used the standard scaler or scaling function. So for that, pre-processing is needed, and for that we need standard scaler. Now what I'm doing is I'm retransforming my data frame using my standard scalar fit transform into a new data set called X standard X scale function basically. Post that, what I'm doing is I'm doing my training and test split. So for that, I need all independent variables in X and all dependent variable or only one dependent variable, that is target variable, in Y. Post that, I'm doing my training and test split using some random state and some test size. After that, just have a look at the data size. If in case you're very particular, you can have a look at it. Everything is good. Moving on, I'm calling my KNN classifier. Now, the first challenge I told all of you is to classify or to calculate the value of K. Now, we have three methods here today. I will show you. Whichever you like, you can use it. Three methods to calculate the value of K. The first method is called a manual method, where manually you will give a data and you will try to find out the values. Second one is an automation. This is what I recommend every time. Do this. And the third one is called a graphical method. So again, I feel this is also easier than the manual method. Now, so we'll start with manual and then we'll go to the other two ones. So if we identify the value of K properly, then the problem is solved. Okay, this is the most important thing. Now, as I told you guys, K should be always odd. And we can choose it between 1, 3, and then it goes up max, let us say 19. Even I have implemented sometimes when the K is a little higher, but these are the standard values. And in your experience in great learning, at least you will not cross 9 or 11, that number. So it will be around 1 to 9, not a big deal. So just to showcase what I've done is, we have first taken K as 3. We are assuming, okay, let's assume K is equal to 3. I am calling my KNN classifier. I am giving a parameter called n neighbors. That means how many neighbors you want. I am saying let my K value be 3. Then I'm using this particular model that I built. I'm fitting it on my training data. I'm predicting on my testing data, and I'm calculating the accuracy score. This is one cycle of manual checking. If you want to check one more value, there is the same cycle repeats again. So if you see here, this is the same cycle. K is equal to 5. We do the same steps again. If you want to do one more value, K is equal to 9, same steps we'll do for K is equal to 9 and print the accuracy. Now, if you look at all the three accuracies, we have 98, 98, 98. They are kind of similar. But if you look at other numbers, I feel this is a correct answer. This is the highest one right now. The accuracy is the best for when K is equal to 5. Okay. So manually we found out when I did 3, 5 and 9, K is equal to 5. But it was a guess kind of thing. So tomorrow, if your K value is around 31, 33, then you have to do it from 3 to 33, which I feel is not a good method. You cannot keep noting down. And in this age, basically automation age, we cannot do this. So this is just in case if you want to check, you can do this. Else, we'll go ahead with the automation part of it. So in automation, it's very simple. The background goes like this. So let me build the algorithm and then we'll move on to the code. The algorithm says very simple. Build a list, okay, an empty list where we'll store all the accuracies, okay, and build the value of K where we are going to store all the odd values from 1 to say 19, for example. Put a for loop, run this for loop K number of times. That means from 1 to 19 you'll run it. And every time when you run this, call a KNN classifier, put the K value inside it as the value of K here, the current value of K for the for loop. And then run your classifier as dot fit onto training data, then dot predict onto the testing data and display the accuracy. In this case, we'll not print it. We'll impute the accuracy in the empty list every time. Okay, this runs till we reach 19. So now if we take the output, this is our output. This will have accuracies from 1 to 19 is how much? Around 10. We'll have 10 different accuracies here. Now what are we going to do? We are going to find the highest accuracy which is here. And if we found this the highest accuracy, which K it belongs to, and we'll say this is the value of K which is having the highest accuracy. This is the logic overall. Now if you transform the same logic into Python, this is how it looks like. So now I have used the range function to put a value from 1 to 19. Okay, 20 is not included here. Then I say I want only odd numbers. So what do? I use a lambda function. Now everybody gets a lambda function, guys?
Yes.
No? Okay.
Yes.
So in this lambda function, what I'm doing is I am just saying take a modulus with 2 of the current number, and if the answer is not equal to 0, that's an odd number. That's it. Keep it. If it is an even number, 2% will be 0 definitely. So we'll remove it. And then I'm imputing the same thing on my list. So these are my actual odd neighbors. That's it. Odd numbers I've created here. Now, next I'm storing an empty list called accuracy scores where I'm going to impute all the scores. And as I said, we have a for loop. Now inside this for loop, we have got classifiers. We are starting with n neighbors with k. So every time the for loop runs, it will have a unique value of k, starting odd numbers from 1 to 19 as shown here. Fit from the same code that we saw above. The only thing is fit it, predict it, and instead of printing accuracies, we are putting in the form of scores, and we are appending the scores to AC scores, this particular thing. I'm using append function. Append function basically puts a comma and creates a new value every time rather than overwriting it. Now, next challenge is I have done a little different. So in our algorithm, I told you that we will find out the k with highest accuracy, or else we can do one thing. Let us say this is our accuracy and this is our error. So let us say my accuracy is 98, error will be 2. My accuracy is 93, error will be 7. My accuracy is 99, error will be 1. So either I say, find me the highest accuracy, this is the one, or find me the lowest error, this is the one. So what I've done is here, I have done the mean sum of errors, and I am saying subtract all my accuracy scores by 1. And then out of that, give me the minimum value and tell me what is the value of k. So if you see here, finally, I'm running an automation where automation will directly tell me that the optimal value of k is nothing but 5. As simple as that. It matches with what we saw above. This was the highest value here, second one, which was nothing but 5, if you see here. Okay, so this is the automated way, this is the manual way. And if in case you want to see the graphical way, in this what we have done is, we are putting a simple plot of neighbors, that is 1 to 19 versus MSE. What is MSE? The variable that we calculated here. So when you do this, you're going to get a graph like this. Now very simple, find a place where the graph is the lowest. So if you see this graph is lowest here. Agreed, everybody? This is what we want. We want misclassification or mean sum of errors to be the lowest. So it also, if you drop it down, it also tells me the k value is nothing but 5. That's it.
Can the results be different for the same data set if we are running on 2 different systems?
I will say not actually, but the result might go a little different depending on our train and test split also. So if you observe here, we are doing train and test split. Yes, so results might go a little different because of this. If in case we change the values here, these two. Yeah, because here random data is coming out, right? That's the reason. But more or less, it will give you the same value of k. So you should not worry about that.
Yeah. I solved the KNN equation, and the answer that I'm getting was different from what was given in the solution of the Metagraph learning. So my KNN is same for all the values more than for k is equal to 5 or more, whereas their values are different for up to k is equal to 9. Is the accuracy scores. But mine is always same after k is equal to 5.
So can you give me the reference? Let me check it out. Why it's like that? Should not be actually, because however you calculate k, these are the only 3 methods using which you'll do it. If you can refer me to that website, or if you share the code with me, I will check it out. What's going wrong there?
Sorry, I didn't get you.
What do I say is, if you can refer that website to me or share it with me, I will check it out. What went wrong and why there was a difference in the value of. Yeah.
Okay, I'll share the file with you.
Perfect. So again, as usual, what do I do is once we have got the final accuracy, so now we got k as 5. When we redo the model, we get 98.98 as training accuracy. Training accuracy, and 98.77 is my testing accuracy. Okay. So now moving on, what I've done is I've got a futuristic value of the data sets, KNN future, some future data set. And then I'm taking the same data set through all the cleaning and whatever we need. And finally, we are able to predict ones and zeros basically. So this is my future data, and this is my ones and zeros. Now, I hope you people observed this during my train and test split. Let me show you again. I have taken only 5 columns for now. Why? I'll tell you. Because when I did with all 42 columns, it took me half an hour, probably not I'll say half an hour, but at least 15-20 minutes for the model to run at least, because there are 42 columns. Yeah. So whenever you want to fixate on the value of k, try with lesser values, and then once you are happy with the value of k, increase or start increasing the columns, or directly shoot from 1 to 42. I don't mind, but just for the sake, I've used only 5 here. Okay, that's a heads up for all of you. So if you are using 5 to train, then you should exactly have 5 for testing also. Otherwise, it's going to fail. Okay. So sorry, I have not used 5. I've used 4 here. I'm sorry. 1 to 5 means it will create from 1 to 4. Okay. So if you have time and if you want to do all 42, keep a time of at least 20-25 minutes. It's going to run, but definitely you're going to answer with a delay because of KNN problem.
This brings us to the end of this tutorial on KNN algorithm in machine learning. Now, before you guys sign off, I'd like to inform you folks that we have launched a completely free platform called Great Learning Academy, where you have access to free courses such as AI, cloud, and digital marketing. So guys, thank you very much for attending this session and have a great learning ahead.